Turns out that in calculus, degree measure is not a very good way to measure angles. Things don't work out very nice because the choice of 360 degrees to make a full circle is somewhat arbitrary. So in calculus, we use a measurement of angle called radian measure. So the idea of radian measure is you take a circle and you put your angle at the center of that circle and measure the arc length, how much arc along that circle lies between the initial and terminal rays, and then you divide by the radius, and that's called radian measure. So on a circle, the distance around a circle is 2 pi times the radius. So if you go all the way around once, right, you'd have a full circle. And the radian measure of that full circle would be the arc length, which is all the way around 2 pi times the radius, divided by the radius, which is r. So all the way around a circle, instead of being 360 degrees, we could also say it's 2 pi radians. Now, radian measure is kind of interesting because you're taking one length, an arc length, divided by another length, which is a radius, then those units cancel. So radian measure is a dimensionless quantity. So if someone asks you about an angle of 15, and there's no symbol indicating what kind of dimensions are on that, you can assume that that's radians. Right? Otherwise, they'd have to put a symbol on it, right? And that would be 15 degrees. Now, 15 radians and 15 degrees are much different things, right? Because all the way around a circle is 2 pi. Pi is about 3.14, so 2 pi is about 6.28. So to get to 15 radians, you'd have to wrap around the circle once, you'd be at 6.28, and again you'd be at 12.56, and then you'd have to go beyond that almost 3 radians. So 15 radians would end up wrapping around twice and ending over here. Whereas, 15 degrees is a very different quantity, right? 15 degrees is just a slender little acute angle like that. So pay attention to whether or not any units are given after the name of the angle. Now, all the way around is 2 pi. Halfway around then would have to be pi. So pi radians and 180 degrees are the same, right? So 3.14-ish radians is about 180 degrees. And a 90 degree angle then would be half of that. That's going to be pi halves. If you wanted to go a 270 degree angle, that would be pi plus an extra pi halves would make 1.5 pi or 3 pi halves. If you cut that in half, you get pi fourths. So a 45 degree angle is the same thing as pi fourths. This would be 3 pi fourths, 4 pi fourths, if we count in by 45 degrees, or pi fourths, 5 pi fourths, 6 pi fourths would reduce to 3 pi halves, and then 7 pi fourths, and you're all the way around. Another angle that comes up commonly would be multiples of 30 degrees. So 30 degrees would be about here. In radians, that would be a third of pi halves, so that would be pi 6. And then if you go 60 degrees, that would be 2 pi 6, or that reduces to pi thirds. Another 30 degrees added to that would make 3 pi 6, right, which would reduce to pi halves. And then you'd get 4 pi 6, which would reduce to 2 pi thirds, and 5 pi 6. And 6 pi 6 would be pi halves, 7 pi 6, 8 pi 6 would reduce to 4 pi thirds, 9 pi 6 would reduce to 3 pi halves, 10 pi 6 would reduce to 5 pi thirds, and 11 pi 6. And then finally adding another pi 6 to that would be 12 pi 6, which would reduce to 2 pi. So you can get used to counting around in radians. We want to do that because in calculus, doing things in radian measures makes everything simpler.